already a critical mass, Andrea. I would, even if we have more registrations, I would suggest to start so that people then can
Will you,
come in.
you introduce, right, Gabi?
Absolutely.
You
With
go first.
super
Okay.
great pleasure. Hello, everybody. While others still come in, I would love to start today's meeting already because there is so much to say, and we have somebody who can speak so well, actually, also, Andrea. It's such a pleasure to listen to you when you speak, and is so well informed and expert that I think it's good to give us more time. What we're doing today is, in a way, from our perspective of our research area, knowledge governance transformation, a special treat for us for the pre-closure phase. We're talking about something that is also our research focus, quantification and the role of statistics in politics. And we do that as the final event of our event series in the cluster on experts, knowledge and authority in politics and decision-making. Just a short disclaimer, at the beginning of the next academic year, we will send again a call for expression of interest, but if any one of you wants to present their research in the next academic year, please make sure to contact us, and we will find a date for you to present to our cluster participants. We are here today to discuss a book that was published last year on the politics of modeling, numbers between science and policy. That's edited by Andrea Saltelli and Monica Di Fiore, and lies at the intersection of modeling, quantification, governance, and decision-making, and with that has many implications on what we're doing in research, but also what ethical concerns, what regards ethical concerns, governance questions, questions of political authority, and with that it touches upon many areas as a book. First of all, obviously mathematical modeling, but also political authority, complexity, agnotology in policymaking, the questions of evidence-informed policymaking, and what Andrea himself frames as the power of invisible numbers in policymaking, which are very important and potentially a huge problem. Thematically, the book circles around climate change and COVID, and I'm happy to see many participants who work on both policy areas. We are here today with one of the editors of the book, with Andrea Saltelli. Andrea has a doctorate in chemistry and himself a very multidisciplinary background. He works on environmental science, on science for policy, impact assessments, on questions of applied statistics, obviously, and has a background both in science advice for a long time, and research himself. From 2005 to 15, he worked towards the end then as head of unit of econometrics and applied statistics in the JRC in ISPRA, and he also holds academic positions with the University Pompeu Fabra at the School of Barcelona School of Management, and with the University of Bergen and the Italian National Research Council. The main disciplinary focus, I guess, fair to say, at the moment is sensitivity analysis and sensitivity auditing, but you also have a strong focus on science reproducibility, apologies for that, and science integrity, also ethical questions of quantification. We talked about that just before you all joined. And with your research and the book especially, you bridge the perspective on statistics, quantification in politics, governance, and the impact of the subsystems on each other in a very, very informed and academically saturated way that is, however, extremely accessible for people who are also not necessarily data scientists. And Andrea, as I said, I'm personally very, very happy because I always love to listen to you, and I'm very much looking forward to your presentation. We said 45 minutes roundabout. You present your ideas and books, and then we are entering into discussion. Over to you. Thank you very much for being here.
Okay, thank you. Thank you, Gabi. Okay, so we can now start this presentation. In case you want to take some of the reading suggestion I offer, you can find a copy of this presentation already on my website, which is very easy to find. It's just a website with my name, and under resources you will find a PDF copy of this presentation. But I will also be willing, of course, to send it to Fiesole for storing on somewhere on their website. I want to start with something which I use frequently when I start this presentation to set the tone for the discussion. We're discussing how much we are surrounded by fantastic number in our life. So this is, according to the New York Times, the most important number you have never heard of, and it is the social cost of carbon in dollar per ton. Two numbers are offered here, 56 and $171, which are themselves the result of some kind of averages. The difference being due to the discount rate of money, which is, as everyone knows, a very parameter difficult to guess, also because this has been based on an analysis spanning 3 centuries into the future, considering the impact of climate on the economy. And this work has been done by very serious scholars, very serious people. And this work also has a political function, feeds into many policy process linked to various negotiations for climate change. In my opinion, and in the opinion of a few people in some of the community I happen to work with, this is pure madness. We cannot predict the economy 3 centuries in the future. Many years ago, in 2010, I was under the illusion or the delusion that I could demonstrate mathematically how crazy this work was by showing that if you reverse engineering one of these models for the damage of climate change on the economy, you end up with a distribution of error that is so large, that you cannot say anything. You cannot say, that is urgent or non-urgent to invest on offsetting climate change, because this was a big dispute between Nordhaus and Stern, two scholars very much involved in this kind of evaluation. Nicholas Stern was a Nobel Prize, and Wilhelm Nordhaus got the Holberger Prize, so they're really very well-known scholars. But their discussion was, in our opinion, futile, because really they could not get a handle on those numbers. This number was clearly fantastic, so neither of them was, in our opinion, right. So let's now, having done this introduction to vent my frustration at the predominance of those fantastic numbers in our blogosphere, let's come to the book. The book on the politics of modeling. Maybe the best things to read is the foreword of Wendy Espeland and the preface of Daniel Sarevitz, which are really almost chapter in their own. They are not just a small text, but contains critical insight in the work of mathematical modeling. Then we have, the book has an introduction by the editor, so Monica and I, and Philip Stark, who is a statistician at Berkeley, has a very provocative article entitled "Pay Attention to the Model Behind the Curtain." Then we have the rules. I will go back to the rules in a moment, but those are rules which were thought of in a manifesto we published in 2020 in Nature. So these rules are for a number of gentlemen you see here: Arnaud Puy at Birmingham University, Bourgogne-Novus University Bocconi, and Stirling Sussex University, and Wolfgang Drexler is a technological institute in Tallinn. Then we have some application. We have other authors: Samuele Lopiano in Reading, Marta Cook-Cernecka is in Gdansk Polytechnic, Paolo Vineis is Imperial College, and Xing Tu, I think, is now in the University of Sussex, moving from Edinburgh. And then some of these chapters are open for, unfortunately, the book is not open. We didn't have the money to make the full book open, but 3 chapters are open, one from Philip Stark, one from Arnaud Puy, and one on sensitivity auditing by Lopiano. Razi, Samuel, you already mentioned Razi is from the Sharif University in in Iran. Best of luck to Razi for the election tomorrow. And then we have some papers which are relatively close to the chapter, which you can read in the open literature from, access from your library. The one from Andy Stirling is close to the unknown, Mind the Unknown chapter, and the one from Ting Su is close to the example of COVID and rule making using mathematical modeling. Also, the epilogue from Monica and I was published in a different form, of course, much expanded as in a journal article. And maybe I will also focus a bit on this one in my presentation. We had a lot of review. This was very good. One in Science, another on the old glorious Minerva journal. But in total, we had 4 academic review. And believe it or not, we also have a page on Wikipedia, which I encourage everyone to work on, because I think should be one of the duty of the academical people to contribute meaningful input to Wikipedia. So this is where the rule comes from. A manifesto we wrote in 2020. This was really a very lucky occasion. The COVID brought mathematical modeling to such a level of evidence that Nature accepted a paper critical of the way mathematical modeling was being used during the pandemic. Of course, the best thing of the paper was the illustration by David Parkins, which is I like very much always when I see his drawing on Nature. But the goal of this book was, in a sense, duplicate or extend what was being done in other families of quantification. And we wanted to bring to light the politics of numbers, and in particular, the politics of mathematical modeling numbers, okay? Trying to make a case. Of course, as you know, those of you who have done some sociology know that the numbers are not neutral, but they are used precisely because they bring with themselves an appearance of neutrality, which is very useful and very functional to offer legitimacy to those who produce those numbers. And they are also performative in the sense that they influence how things are then seen or done without appearing to be performative. So this is really what has been called the seduction of numbers, by Sally Engle-Mary recently. But this book of Porter, which you can find also on the open in the web, is very good. Otherwise, I give you another article from Theodore Porter, who is one of the fathers of the sociology of quantification. So I mentioned sociology of quantification, but I would like to stress, as Gabi mentioned, that numbers can be visible or invisible. I would like to convince you that scholars of sociology of quantification tend to discuss in the same box both the visible number of statistics, GDP or employment rate, and mathematical modeling, infection rate, number of deaths from COVID, and the numbers that you don't see. For example, the number whereby you are denied a mortgage by the bank because the bank is using an algorithm, an artificial intelligence-based algorithm, to decide that you are or are not eligible for a mortgage. So these numbers, in a sense, come together, okay? Come together because it's very difficult to distinguish them. You use modeling to do statistics and vice versa. Artificial intelligence, there is a lot of modeling into it. Machine learning, what is machine learning if not, a very intricate multi-steps exercise in modeling? So it's difficult to even a ranking, a stupid ranking has a lot of modeling inside to decide how you rank the variable, how you weight them, how you aggregate them, and so on and so forth. And this is what makes those numbers, in a sense, belonging to the same family. Now, I want to make a small digression to see that this pervasive presence of numbers is not without consequence also for policy, because quite a number of different people coming from different traditions have sounded alarm, saying that this regime of numerification diminish the democratic agency of the citizen and lead to a form of a-democracy, which we a-democracy being something which sounds like democracy, but it's not a democracy because citizens have no agency. The books I present here, which are only a sample from a much wider possible set of books, are from one jurist, Sue Pyo, data scientist, Katie O'Neill, a philosopher, Byung-Chul Han, Shoshana Zuboff is an economist, and the last one I read from Dan McQuilling is a science and technology scholar, in a sense, an STS scholar, but he was a physicist to start with. And for some people, like for instance, for Slavoj Zizevich, one consequence of this a-democracy is that people end up into identity politics. So the story is that if you take away from me the possibility to act as a subject of policy in the usual sense of the term, dividing between left, center, and right. So if you decrease this kind of political agency, what is left is identity politics, my sex, my religion, my nationality, the color of my skin, and the like. And I think the reason why I made this digression is that this kind of stuff is also among the things which interest the European University Institute cluster, for which Gabi is very much interested. You see the cluster here, the thematic priority. So democratic accountability, democratic life is also an important theme. We argue in the book that mathematical modeling live in a state of exception, no? From Schmidt, you know, state of exception, like if they are some kind of king, some kind of authoritarian character. Why do they have this state of exception? Well, I think that mathematical modeling has a unique repertoire of methods, even more than statistics. It has a lot of epistemic authority, which come from being mathematical. So mathematics is epistemically very authoritative. So authoritative that for many philosophers, mathematics is a language of God. You remember Galileo, no? The language of God. And those who want to demonstrate that mathematics is not the language of God, but is something which men create with their action, like the cognitive psychologists George Lakoff and Nunes, you know, it's not easy. I mean, this book, which I show on the right, where mathematics come from, is really an attempt to show that mathematics is, in a sense, not the language of God. But this is an unfinished business. And by the way, I should also say that calling mathematical modeling mathematical is a bit of distortion, because many things enter into a mathematical model besides mathematics, but we will say more about that. For some people, modeling is not really a science, but more of an art, for Foster Morrison, or a craft for Robert Rosen, a relational ecologist. No? Robert Rosen says that if I look at a natural system and a formal system, both systems have their own internal causality, but no causality goes from left to right. Going from left to right to encode is left to the craftsmanship of the modeler. Okay, this is an important subject, but we leave it there for the moment, and those who are interested can read the book of Robert Rosen. So mathematical modeling, in a sense, fly under the radar of sociology, because sociologists are much more involved, at least as far as I'm reading, with other forms of quantification. Maybe the only form of mathematical modeling which sociologists have studied to a certain extent is cost-benefit analysis, which is maybe not even so much mathematical modeling. An exception to this is the book of Morrison and Morgan, Model as Mediators, which is a very interesting and deep book, not easy to read, because the people who wrote this book know very well the sociology, but they also know the subject matters of the models which are described in the book. And this is perhaps the reason why there is not so much sociology of mathematical modeling. It's simply so difficult to be cognizant in both things, no? This is an article where Arnold and I discuss how mathematical modeling can escape the sociology of quantification, and how the two fields could have a better dialogue. No, okay. There is in mathematical modeling, as in statistics, a need for equality which has a double dimension, technical and normative. In a sense, this comes from statistics/economics, because Robert Saleh, who writes in this book, which you can find open access on the web, Robert Saleh borrows this from Amartya Sen. Amartya Sen, discussing the quantification and discussing how the quantification needs a normative dimension, make the example of the capability approach. No, it's not enough for two people to have the same amount of good, because they may have different starting positions. So the amount of good should be such that each of them can reach a certain objective or their own objective, not simply receiving the same amount of good. This is an example of how fairness can enter into a quantification. Mathematical modeling are extremely malleable, no? Because in statistics, you have somehow to cheat with the data to achieve some kind of desired inference. But in mathematical modeling is even easier. Saleh talks about the bad statistics as the reversal of the statistical pyramid, governance-driven quantification. In my jargon, in the jargon of impact assessment, you distinguish between evidence-based policy, which correspond to good statistical work, the one done by official statistician in creating good indicators, to policy-based evidence, which is when you do the indicators just because you want to prove that a given policy is effective or needed. Another reason that models are so difficult, are so exceptional, is that they cannot be falsified. You cannot prove that a model is wrong because normally the model is co-created with its own data, and so it's difficult to use the data to disprove a model. Some authors have spoken of an incestuous relation between model and data, which is especially true when models are too large. So when models, for this reason, it's easier to use model to disprove something than it is to use model to prove something. Okay, because models are not physical law, whereby you simply compare the theory with the data, and if the data don't match the theory, in principle, but not always, you can say that you discard the theory. But models are a construction which include a lot of assumption, presupposition, secondary hypothesis, choice of resolution, algorithms, and so on and so forth. So when they are wrong, what was the problem? The input data, the model, any or all parts of this could be wrong. So it is really difficult to to say that a model is wrong in a certain sense, no? And this is a bit like the Duhem-Quine critique in sociology, no? That you cannot discard an hypothesis with some evidence, because the hypotheses come with many other secondary hypotheses. So also in this case, it's very difficult to distinguish what went wrong. And then but on the other hand, models are very successful, very much needed. They are fantastic in how they can operate between mediator between a theory and reality. Now, many scholars have said that the modeling is one of the most important activity you can do if you are in a science profession. So really, also this makes model pervasive. You know, some scholars talk about invisible science. I think it's Stephen Shapin, but you could also talk about invisible model, those models which we don't see, but which make our life in a sense easier and create a few problems. Also, model can be thought of as an image, a snapshot of how we perceive the world. Now imagine an archaeologist of the future will study our mathematical modeling, and based on this, understand how we perceive the world. And at the same time, models can be used within communities to deliberate, to analyze an issue. So model can also be part of some kind of participatory process in a context of, for example, an extended peer community. This is a concept which comes from post-normal science. And then one of the, now there are a number of consequences descending from this state of exception. One is there is an incredible asymmetry between developers and users. But I would contend that the asymmetry is larger for mathematical model than it is for statistical indicators, okay? Because, okay, but this is based on my own experience. I don't know if you agree on that. And then there is also that the fact that model can lend themselves to ritual use. This is a very nice example from Kenneth Arrow, who was asked to produce during the Second World War. He was asked to produce a prediction of climate 2 weeks ahead, and he said, "But this is horrible. Doesn't serve anything. It's not, this prediction is not good." But he was told to keep doing this because it was needed for planning purposes. No, so you see, there is this kind of ritualistic use of model, which is not unknown in statistics. No, if you have, if you know Gigerenzer has written a lot on the ritual use of the p-test, for example. No, people use statistical inference ritualistically without understanding really the implication of the use of those inference method. Okay, so there is the story of transscience. No, I have here an example of a question which sounds scientific, but which in principle you should not be able to answer scientifically. How many people will sit in an autonomous car by 2050? How will the spread of malaria change if global temperature increase of 1.5 degrees centigrade? And what will be the cost of CO2 average over the next 3 centuries? Clearly, some people is very active at putting number on these 3 things, but this is what precisely Weinberg would have called trans science. And there is also, of course, because as one of the consequences of the state of exception, that the possibility that model could damage. So, and this can be in medical research, in higher education, in finance, in the governance of science. This is a book from Mittelman on higher education, the impact of higher education ranking on the higher education. The book of Richard Harris is on medical research, and the book of Wendy Aspeland is also on the ranking of higher education. But there are many, many other examples which you can find. Well, this one which I like very much because I worked on it is one on the OECD PISA test, which is very useful for educationalists. But when we reflect on, was PISA useful or was it damaging education? Probably, you know, the on balance, it was damaging. Also because there is always one more method in quantification which will be good, the gold standard. No, then there is always one new method to add to the palette which will solve all problems, like randomized control trial or sophisticated statistical econometric techniques. But again, all these methods suffer from what is today being called analytic flexibility. Now, this is very recent. Now, very recently, people have realized that econometric analysis are flexible, meaning by this that changing assumption, the result can change a lot. This is a field where I'm also working at present. But many of these things are also discussed in the article of Schoons and Stirling on this book, which is also open access. You can read it online. Okay, and okay, I mentioned the rules. Okay, these are the rules which were in the manifesto. But if you want to see more example of good or bad use of model, you can go back to the manifesto and also to the supplementary material where we had to compile, no, good and negative example of mathematical modeling. Mathematical modeling used properly, and mathematical modeling possibly being used improperly, no. One consequence of this state of exception is that we see one-to-one map of the empire. I hope that in the audience today there will be many readers of Jorge Luis Borges, this fantastic Argentinian writer who writes about a map which was so big as to cover as the entire empire, because it was a one-to-one map, no? And we are now discussing really in these days to do a similar map, a one-to-one map of the planet, including its economy. This is called Digital Twin of the Earth. In Europe, this is called Destination Earth project. Of course, as you can understand, I find this project not terribly useful. For is really a big case of hubris. If you don't believe, look at what is written on Euronews about this project. A complex computer model takes into account weather, climate, as well as our impact on the economy. Destined Air is a true game changer in our fight against climate change. Today, the future is literally at our fingertips. And here in this image, you see how the planet is perceived, into the mind of those policymakers. Really, there is a switch, we can move the switch. And, I mean, this is really, when you think of after, a couple of centuries of ecology, I guess all the ecology in the room will be now crying. Anyhow, so clearly this kind of mathematical modeling is also functional to make promises which are empty, no? There are a lot of promises going around of a circular economy. There are many things said about energy transition which don't correspond to the reality as simply promises. And if you look at this with the lenses of bioeconomy, of relational ecology, you can find it and you can debunk those narratives. This is a paper, but if you read the book of Václav Smil, you will see how many of these promises are really not based on actual numbers, no? So in this article, we talk of the economy of techno-scientific promises, no? Promises of why those are empty promises? Because those are promises that we will keep doing everything as we do today in terms of consumption, no? Simply because technology will offer us new way to do what we already do. And this is what clearly will not work, because technology will only be able to increase our consumption. We argue, you may disagree, but not easily decrease our consumption, because decreasing consumption implies politicians doing something as opposed to relying on the promises of technology. Then models can act as chameleon. We have seen this during COVID. No? During COVID, we used a model of Ferguson of the Imperial College, which was a study model, agent-based model, a big model. And this model was used to make prediction for policy. Probably this was not the right model for doing prediction on policy. A much simpler SIR model would have been equally effective. But they can be chameleon, because they can say, oh yes, but we are only study models. No, when someone objects, but why are you using this model for policy? Oh yes, you are right. We are only study model. We need more research and more data. We have seen this several times. No. About the model hubris, this is something we discuss in several papers beside the book and in the manifesto. When you build a model, you normally make the model better because you increase its descriptive capacity. But as you add modules, parameters, equations, all this needs more data, and each datum comes with some error, so that the error will start increasing again, and in the end, the model will be, totally unreliable, simply because the error is too large. So the model is complete, contains many things, but the result is too uncertain to be of any practical use. So there is an optimal point of complexity for a given level of evidence. No, what are the solutions to this? Well, I think we can take the example from the statistician again, because they have, for example, a current especially active in France called stat activist, which fight a number with a number, or under the slogan, a better number is possible. We can do in mathematical modeling the same thing using sensitivity analysis, sensitivity auditing, which is an extension of sensitivity analysis, or modeling of the modeling process, which today is has been rediscovered under the name of multiverse analysis, which is a more catchy name, I admit. But with this kind of technique, you can deconstruct and reconstruct a quantification, okay? You can deconstruct a bad number and possibly construct a better number. And to do this, you must retrace what was assumed and then check, for example, the level of complexity, and then, you know, do a number of this kind of analysis, no? One thing you can do is not quantify. You know, some numbers are really funny in a sense, no? When I was mentioning the bad numbers of finance, there is, please read this very short piece. This is a funny piece of Theodore Porter about funny numbers, on how these numbers look very serious on the surface, but as soon as you open the hood of quantification, you see that they are totally ludicrous. Which is the point made by Porter in his article, in any case. And then we believe more time can be spent discussing models than constructing them, in the sense that, for instance, many years ago, we had a big discussion on the iPad model, no? That the impact on the planet is proportional to population times affluent times technology. This is a very stupid model, a simple linear equation. But with this model, a good conversation could be had on the limit to growth. Okay, you may say this is an extreme example, but this gives you an idea of how you can discuss important policy dimension also based on a very simple mathematical modeling. And then people, so I mean, this is happening already, you know, society is now more alert to these things. And then what we want to achieve is the reciprocal domestication between models and society, you know. Here is an example. When there was COVID, many different policies were enacted in different parts of the world. And yet everyone was saying that they were following the science. No, but if everyone was following the science, then something was wrong with the science. So clearly science was not speaking perhaps with one voice. This is how people become, after COVID, generally more, in a certain sense, skeptical of expertise in general, but this is also another, this could be the subject of another seminar probably. In post-normal science, there has been a long discussion on this, especially in relation to risk analysis, no? The numbers of risk analysis are foggy, no? They should be defogged. And this is a discussion which is also very well practiced by the ecologists. No? If you read Langdon Winner, Mumford, or Ivan Illich, or Schumacher, all these ecologists have written similar things. Now that those numbers of risk analysis, cost-benefit analysis, you know, should be looked at with a certain skepticism. Here is also, again, of risk analysis and cost-benefit analysis, and to use more the lenses we suggested in this part, following Georgios Korogan, and then approaches originated in the context of science, such as scientifically developed already in the 90s, quantitative storytelling and other approaches of this kind. And we do this because if you linearize quantification, you generate invisibility. There could be an invisibility of qualities, well, if you use Ricardo's theorem, but if you don't use bioeconomics, you will not carefully apprise the existence of something called entropy and the fact that natural resources are not infinitely substitutable. If you use post-normal science, you will not be blind to the contamination between facts and value, which is obfuscated by the purported neutrality of quantification. So I conclude to say, this is my last slide, that precisely, what was it, 40 years ago, this man, Brian Wynne, which is a very critical STS scholar, one of the best, debunked a very big assessment of the energy future done at IISA, no? The agency in Vienna. This big report predicted that in 2030, so practically now, we shall be mostly using three sources of energy. Fast breeder reactors, which is not normal nuclear reactor. Those are nuclear reactors which generate more fuel than they consume and which are normally now only used for military purposes. We would use then centralized solar, meaning gross plant concentrating solar energy and not what we are having now. And third, synthetic fuel from coal. None of these three options did materialize. And if you look at the image on the left corner, a fast breeder reactor in the Netherlands is today an amusement park. And what I want to say is that this is a kind of, the report of IASA prescribed scientifically that this will be our energy future, the same way the proposer of digital twin tell us that digital twin of the planet are scientifically prescribed by our technology. I think I stayed in my 45 minutes, and there are extra references and maybe extra slides if you're interested at the bottom of this, which you can find. Thank you very much.
Great, thank you very much, Andrea, and thank you for also linking it always to the academic debate, which is very interesting, you know, to see where the schools touch upon each other and potentially not speak to each other. We actually open immediately the floor for Q&A. Raise your hand, please, and ask your question if you want to. I'm monitoring that, but if I overlook something, just open your mic and ask. Andrea, all of what you said culminates for me in three types of questions. And one question, because Raffaele and I talked about that over the coffee break this morning. Maybe this question before, as you said, this asymmetry between mathematical modeling and statistics, the use, and the question of transparency of it. And you said that's more or less the same. And we actually said, no, mathematical modeling is still a bit less tangible for policymakers potentially, because a number or an index gives you an impression of materiality and is a bit more tangible. It would be great if you could develop this a bit more, why you say it's actually the same in terms of the asymmetry between users and producers of the modeling. The 3 points that I wanted to make is when you say that, and you wonderfully with the last slide brought in what I wanted to ask, the relation between forecasting and foresight for policymaking, because part of what he does is indeed foresight, right, with the models that he develops that are based, however, on his forecast work, I assume, and the forecast work. So if we think once of modeling, future-oriented modeling, as an instrument of politics, where do you see the limits of that? And where should developing ideas for the future become more democratic? Where can we have this democratic perspective on the future? And where do we need to democratize thinking of these models, like a fast breeder reactor, in a more democratic way to make these ideas fly for the future and not just remain in a very limited group of actors prominent? In line with that, I'm wondering if modeling can actually always only extend reality rather than be path-breaking by the very nature of it. So if we're too much engaging in integrating mathematical modeling as a policy tool and a mode of governance, will we foster a path-dependent development rather than a path-breaking because of the methodology of modeling? And finally, what is the role of the scientists in all of that?
It's 5 then.
What is the role of scientists?
I counted 5 questions. Then now
no, it was under bullet points. What is the role of the scientists in that? You know, asymmetries, relevance, and for literacy questions, how to convey the limits, the limitation of the methods, how to add disclaimers, methodological ones, to make users of modeling understand the inbuilt limitations potentially. And I leave it there. Everyone else, please come in.
Yeah, thank you.
Thank you, Gabi.
Okay, I have 45 minutes, right?
3 hours.
No, okay. No, mathematics and statistics, I say, I wish mathematics were like statistics. So it's two different things. Mathematical modeling can be as influential as statistics in policy. I stand by this, though you maybe disagree because you, Gabi, come more from the school of official statistics. So you know more of this other side, but I know more on the on the mathematical side. So I believe these two are comparable in their effect on policy. They are really both quite powerful. But unfortunately, statistics is much more, in a sense, transparent, or at least is more studied by sociologists and has more reflexive in itself than it is mathematical modeling. This was all what I tried to see. When you talk about forecast versus foresight, of course, what's wrong with foresight? Nothing is wrong for foresight. The point is, like, again, this story of the chameleon, no? I do foresight, but then in the policy brief coming from the foresight report, one read that this is scientific prescription. So what was a foresight becomes a prediction which we have to comply with because science has spoken. So again, there is this ductility, no, which I think should be resisted. Then what we should do to democratize all this, I don't have a solution there, Gabi, because democratizing science is a very, very hard task because those who have power can normally also, in a sense, hijack this process whereby science is democratized. So a lot of vigilance is needed. No? In the case of the stat activists, for example, they made important alliances with institutions, like, for instance, in France, the INSEE, the statistical office itself, and the media, the journal Le Monde. Without those powerful allies, the statistician of the statistic movement could not really fight the fight they fought. So I don't believe there is an easy way other than for people like us try to suggest strategy of social awareness or social resistance. But no, I agree with you that the impact of all this on democracy is really something but probably, this would be the subject of a new seminar if we were to discuss in what level quantification could be used as a tool to democratize expertise instead of deprive people of political agency.
Now I go with the mic open. Great. Thank you very much, Andrea, for that. What is interesting, I think, to look into is how statisticians, modelers, data scientists working on models could or can interact with policy in order to make the models more understandable to policymakers. Do you see anything along these lines happening? So what we see in the International Statistical Institute, for example, are until 25 with the new activity program is a boost of activities to interlink more with society, to bring statistical literacy into society, to make basically statistics an everyday life experience so that people can understand better how politics are informed by numbers. Is there a role to play for mathematical modelers as well, or is that too complex? Because as you rightly so said, these the distance, still language of God in some people's minds of mathematics from policymaking present day. What do you think of that?
No, I fundamentally disagree. I don't believe modelers can be relied to make by themselves the effort to become transparent, precisely because, as I tried to explain, part of their epistemic authority derives from being non-transparent. And so they will not relish this voluntarily, because this is what provide their, in a sense, their funding and their living. So I believe only a reaction of societal vigilance, can keep modelers straight, can force modelers to open the black box of their tools, precisely as the people in who do ethics of algorithms do when they do hackathons, and they open the algorithm to reveal to the society the preconcept, no, the bias, even racist bias hidden inside the algorithm. So I don't think this will be done. Exactly how the developer of algorithm will not do this, so the modeler will not do this themselves. Someone else has to push in this direction and force them to do this.
Is there enough knowledge on the side of policymakers and those engaged in preparing politics to actually catch up with the latest developments and opening really up the black box? What do you, for example, think of these MIDAS database that has been developed by the European institutions to take stock of all the modeling that goes into EU regulation? Is that something that is workable, or do you need a high level of expertise already to understand these tools of insight?
Okay, this is open another chapter, and this is the chapter of a deficit model. Scholars like Brian Wynne, for instance, the one you see here, have made a lot of work to debunk the so-called deficit model, whereby people cannot participate in the making of policy or take irrational choices because they don't know the science. This is a wrong concept. People has to become aware of the power of certain tools, and then they will be willing, you know, to contrast them. It's not a matter of educating the public so the public will understand that we have taken the good choice, because very often the choice has been taken by institutions which have a certain view of the world, but the stakeholders may have different views of the world. That's why we say we need more lenses, no? But the stakeholders and their view of the world will become, will become agency only when society will discover, in a sense, no, the power of those tools and will decide to do something about that. For example, with the unions, with the media, with other forms of intervention on society. It's not something whereby there is an education step and then an agency step. And maybe the other way around. There is a need for agency, which then generate the citizen desire to know more about something.
Do you think decision takers need to understand the input side of models, so the assumptions of models to take better decisions? And how?
Sorry, I didn't understand. Can you repeat?
So if we look into models, there are a lot of assumptions and normative claims, conceptualizations that frame a certain normative idea that goes into the model. You said that with your mortgage, at times also rental contracts, things like that, right? Do you think policymakers need to understand this input side, so the assumptions behind models, to take decisions for policy that is designed based on modeling?
Yeah, but those are two different things. The detail of the model and the assumption are two different things, because very often assumptions are a very high level, or a very assumptions are normative. No, the economists talk about mattiness. I don't know if you heard the discussion. No, Paul Romer said the economists do mattiness. Mattiness. What is mattiness? Mattiness is doing a lot of equation for, you know, creating a growth model, but then what is at the root of this growth model is a certain vision of society. For example, a neoliberal or neoclassic vision of market as the solution of all problems. So one thing are the assumption, another is the complexity of the model. Politicians should better understand the assumption behind the model, not the intricacy of the mathematical modeling itself.
Yeah, and is that transparent? Do you think that is transparent in policymaking as far as your insight goes?
As I said, you know, Luhmann, sociologist Luhmann says that politics use science to deparadoxify policy choices. I agree with Luhmann. So policy choices are mostly dictated by what is feasible or desirable at a given time. And most often we see science used as a tool, no, to deparadoxify Why paradox? Because each policy choice has winners and losers. So each policy choice can be presented as a paradox. How do we justify the paradox? With science. How can science justify such a paradox? By becoming linear and reductionist. So you see there is a kind of circle, not the perfect function, which should be broken.
Yeah, yeah. Well, can this be broken in, for example, types of visualization, like in the 6th IPCC report, that very much goes into the direction of presenting different types of, different modeling of different assumptions, worst case scenario, medium trajectory, also a bit like the population demographic forecasts. Is this way of visualizing also the margin of development options a way to go, or is that counterproductive for the use of modeling in politics? What do you think? Because it doesn't reduce complexity as much as policymakers would want to.
I'm not a big fan of the IPCC because I think, I believe at the end of the day, however they honestly try to quantify the uncertainty, the message which emerge is systematically that we are all going to die because of climate change. Sorry to say that, but this is the message which, when I open the television and listen to Al Jazeera, the world is about to be annihilated by climatic change. Now, there are a few people who try to contrast this narrative, not to say that we don't have climate change, but that climate change is one among a number of very serious problems we are having at present, which are not only environmental, linked, for example, to pollution, to use of different kind of resources, but also socio-political, geopolitical, no, which are really dramatic. We live in a moment where, but we are surrounded by people, and the IPCC, one of the actors, who see that climate is the defining cause of all these problems. No, so the war in Syria comes from climate change. The war in Sudan, even the for Latour, before he died, he wrote that the war in Ukraine is also due to climate change. I believe with Mike Hulme and other scholars that this is not the case. I mean, you cannot take climate change to be the cause of each and every disaster happening in our society. And this is also very dangerous because it's also be used by, by unscrupulous party, like, for instance, the Syrian president, to justify his failure to contain disaffection in his own country and the resulting revolution. So I think that the debate on what to do should not be within IPCC, but should be on a broader societal kind of context.
Yeah.
Otherwise, I don't know, maybe this will solve itself in the sense that IPCC will become irrelevant. People will stop worrying about that because they will have more urgent concern. And you know what I'm talking about, no, I hope.
Yeah, that's what I mean. First of all, I do assume it's quite normal that IPCC has this strong climate change focus because that's their mandate, obviously.
It's a mandate, of course.
To do the research on that.
Yeah,
exactly. I assume to escape this scaremongering perception, they work with different probabilities also in their visualization, which I find actually quite appealing, to say it is a trajectory, but how intense this trajectory might become depends on current policy action to inspire policy.
Sorry, again,
activity.
I did not. Can you repeat again? I did not understand.
Global warming. They when they visualized their trajectories, they give different. So 1 degree, 1.5. So
yeah. No, again, really, no, Gabi.
But this is a different policy.
For me, this is all science fiction. I mean, they say that the climate will stabilize at a certain temperature if we don't increase, which is above 1.5 degrees centigrade, if we don't increase the CO2 level in the atmosphere above 450 parts per million. This is science fiction. Every ecologist knows that nature doesn't move from one state of equilibrium to another state of equilibrium. We don't know. I mean, all these presupposition is based on a very bad mathematical modeling, which has which contradict what ecologists know. Normally nature either is elastic, so goes back, or is indifferent, so moves along a continuum, or catastrophic, the system collapses and go to a very much different equilibrium somewhere else. The idea that this idea of the 1.5, the decrease scenario number 1, scenario number 2, all this, has really a kind of very scholastic. It makes me think of when people were calculating how many angels will sit on the tip of a needle, because this calculation, are not worth the computer they run on, because they are really fantastic. They presuppose that you can model, you can model the environment over, decadal processes, and this is also a huge assumption. But you can also model the economy. This is sorry, but there are people who believe this is totally meaningless. But you see, this has a political value, because if we do that, people get the impression that we are in control. So we are still into the Cartesian dream of man, master and possessor of nature. We can turn, in the graph of the European Commission, we can turn the thermostat, but no, this is not how things are going. This is only to give the impression that we are in charge. But we are not in charge, in a sense. Well, it seems to me that we, and by promising that we can be in charge, promising fast avenues for decarbonization, for example, only increase the frustration of society, especially the young people, who then become frustrated because they say, oh, you politician talks every day about decarbonization, but we don't see this decarbonization. Of course you don't see this decarbonization. This decarbonization cannot be achieved. If you look at the history of energy, you had transition very mild, like the transition to use liquefied natural gas, which took over a century. So if we take a century to move from gas to liquefied gas, because we have to build a ship to transport it, the liquefying plant, the gasification plant, and so on and so forth, how do you believe society can decarbonize by 2050? This really doesn't make any sense. And these kind of promises only increase, in a sense, the frustration of people. And this is in large part the result of activities of quantification which are presented as scientific and neutral.
This actually leads me to something that I previously said, where I want to go into a deep dive, and reminding you again to come into the discussion, please, all of you, with your questions. That actually was something that I meant when I talked about this path-breaking opportunity enshrined in modeling, yes or no. So what we saw within the Green Deal, very much along the lines what you said, Andrea, is that policies are currently designed to decarbonize the way we live, right? Rather than developing a different alternative lifestyle that is in itself less resource intensive and less emitting. And is that mirrored in the way how models, of the types of models that are developed? Do you know of any modeling that has this path-breaking, is based on path-breaking assumptions? Or is that rather an extension of the present rather than breaking?
Oh, I see. We have
and
also
Franziska, maybe Franziska's
yeah.
question to come in immediately so that we can group them together. Franziska, please.
Yeah.
No, feel free to answer that. I think my question goes a bit in a different direction, but thank you.
So the path-breaking potential of modeling.
Sorry, I did not understand.
Do models have a path-breaking potential rather than a path-dependent potential in policymaking? What do you think?
Yes, I believe there have been very virtuous example in that. I made the example of the iPad model. Model can be really instrumental in showing perspective, reality in a different perspective. When you use quantitative storytelling, for example, you can use mathematical modeling to show that something is impossible, for example. Now you can show that something is impossible because, for instance, impacts on the biophysical limit of our economy or planet, impact on the way we do legislation in different countries, or impact or bumps against what people want to do. Now imagine I say, okay, we want to consume less, everyone has a hot shower only once a week. Probably people would not like a policy aimed to reduce the number of showers, hot shower, to once a week. And this goes into the desirability direction. Not always you need model to do that, but very often you can use model to use in this. This is what Oreskes was saying. Now you can use model very efficiently to show that something is not possible or is not the case.
Great, thank you. Franziska, please.
Yes, thank you very much for the presentation. I think it's really, really interesting. And it also relates to some questions that are a bit more practical that I've been asking myself for quite a bit by now. And I would have two questions where I would love your like expertise or your idea on those. The one is kind of refers to what you have already talked about, which is, okay, we have decision makers, we have politics that are informed by modeling, such as COVID, such as 1.5 degrees, so like a climate change, global warming aim. But on the one side, they give a lot of uncertainty to citizens, as you said, rightfully, because politicians cannot follow up with that. Like it's basically like decarbonization, as you said, like it's impossible. But at the same point in time, it also gives at least some sort of trust or like something tangible for citizens who don't necessarily understand the complexity of the subject, but they have a number and they can associate something with the number. Obviously, if then it doesn't work out, it's another problem. But I was wondering how we can change this then. Is it a question of being more transparent about how subjective modeling actually is, or that mathematics is not necessarily, doesn't always mean the same? Or do we need to have like less high, lower political aims, or just general change in discourse? I would really like your input on that. And another question I had was more related to the student side. So my background is in political science and in communication science, and I see with a lot of students, but also with a lot of researchers, that the more complex the model is, the better it is. So this approach that you need to have not simple models, but the more complicated ones that people don't necessarily understand. And I see it especially now with LLMs that are coming in, GPT. And I also see that very encouraged by, for instance, the EU. When you are in a EU Horizon project or you have an ERC grant, then it's really encouraged to use these kind of methods. But then at the same time, if you don't understand it, and like you said, with the p-value, for instance, you don't necessarily, you have an idea of what it is, but you don't really understand it necessarily. I think that it has a lot of problems with it. And I was wondering if you had any suggestion on how we can deal that. Is it a question of changing education, or like improving peer reviewing processes in journals so that we can ensure that it's properly used, even though people don't necessarily understand the mathematic calculation behind it?
Yeah. Okay. I believe that you asked me if I have recipe which, in a sense, are technical, which I might have. No, make model more transparent using sensitivity analysis. Yes, of course. This is my business. Most of the time, I work on uncertainty and sensitivity analysis, but I think the solution is even more on the political dimension. When you were talking, especially your second question, I wanted to point you to this very small book by Dan McQuillan, Resisting Artificial Intelligence. And he talks about anti-fascist approach. You could say, oh my God, this is a big word to be used. But in fact, he developed the argument in a way which I found very convincing, that ultimately those big models are fascist in that they, in the way they are used, they become like bureaucrats. Now, maybe you heard the story of Hannah Arendt, of the process of the Nazi Eichmann in Jerusalem, no? When he was tried for massacre of Jews, and he said, oh, but I was only a bureaucrat following order. the point made by Dan McQuillan is, well, imagine that instead of a bureaucrat, we have a bureaucratic algorithm, no? So the algorithm are by their nature very bureaucratic, and even less than a bureaucrat, you cannot appeal to them, no? So really in a society, as Supio also, you know, the one of the book on the left said the same story, a society which is governed by algorithms, no, is a society where citizens have no appeal possibility. So Supio talks of re-feudalization of society. McQuillan talks about fascist society, but they are saying the same thing in a sense. No, we are, and also Byung-Chul Han talks about along similar lines. No, so it's not so much a technical as much as a political issue of which we have to become more aware. I hope, and for young students, this though. Then you mentioned the funding. This is a tragedy because young people need to receive grants and funding, and grants and funding are given, distributed, following pre-established narratives. So you will never get €1 using my idea to prepare an application for a grant. I advise you using any of my idea to prepare a grant because you wouldn't get €1. Because if you want to be funded, you have to go with the digital twins, no? So even if you are talking about, even if you are studying, I don't know, rodents, you have to say that you want to do a digital twin of rodents, and then you will be funded. But, you know, then the proletarianization of research would be another topic, but probably for another seminar. Maybe there is one more question from
Raffaele.
Raffaele.
Yeah, so first of all, thank you very much for your presentation. It was really, really interesting and gave us so many insights and interesting ideas too, and approaches to look into. My question was related to a bit to the critique you made on the IPCC and this kind of thresholds that are given that are very artificial. And I agree with you with this, but maybe this is just a thought. Maybe this kind of thresholds are easily understandable by policymakers. So it's like they don't have to be really like reached or respected in some way, but they're like they're put there as a I don't know, an easily understandable like policy objectives that then they should follow. Then, of course, I understand that there could be like this. This can lead to confusion because we think that then that's like science and it's like how nature will react to. So after 1.5 degrees or after 2 degrees, there would be like a catastrophe, but we don't know exactly how the ecosystem reacts. So don't you think that those are maybe good like policy objectives rather than just science advice?
I must confess that when the discussion goes on climate change, I feel unhappy because why am I unhappy? I'm perfectly aware that when we discuss climate change, everyone reaches for his gun because, or her gun, because it's a very normatively loaded topic. No, so really, this is not the place where you can have a reasonable discussion. I feel much more confident, for instance, when we can discuss hydrology, irrigation, water need, projection of water need, even some decades into the future. This is where, you know, people can still have a discussion, you know, without using guns. When it comes to climate change, the normative, you know, the temper runs high, the normative dimension is overwhelming. The conflict of values underpinning looking at climate change versus geopolitics, for instance, is so big that it's difficult to discuss this in the context of a presentation where we are supposed to discuss how to properly use a mathematical model. That said, I don't want to disagree with you. In a sense, we say, let's use numbers as anchoring devices, okay? And I'm not against that, no? But what anchoring, what number for what, for anchoring what? So I'm not against generating an anchoring number. For instance, if I run a mathematical model to use the need for a minimum wage in a certain country to be raised, no, to a 20%, this 20% could become an anchoring number, could be based on a model, and could be something more reasonable to act upon, no? Okay, also because of the time scale involved. So it's not per se the use of numbers which are just anchoring, no? So those numbers, we, in a sense, let me use the term, we make up them. No, we create them, you know, because there is a part of analysis, but there is also a part of advocacy in the way we create them. Maybe I can use some kind of statistical indicator. So I'm not against that, but what one should reflect is what happens with this anchoring number, no? The policy which follows, no? So if the policy which follows from this 1.5 degrees centigrade target are a policy of empty promises, no? Which you all discovered, come on, you have all seen that those promises are empty, you know, the Paris Agreement and so on. So because why? Because you are not told not to fly. You are not told to reduce consumption. You know, nobody's being told to lower the level of consumption, because if you touch growth, no, if you touch growth, everyone panics because everything is based on growth. The economy collapses, you know. So we politicians are obliged to promise you that you can keep flying, no, and technology will make flight less polluting. Voila, no. So this is, in a sense, is a true paradox, no? That we create anchoring numbers which force a policy cycle made of promises, which eventually generate frustration, and eventually, you know, we generate the kind of authoritarian outcome Slavoj Žižek was mentioning at the beginning of my presentation.
That's a very, sorry,
also,
no.
Thank you. Okay, I see the point, and I understand, because even, I don't know, a more comprehensive use of number, like I don't know, the planetary boundaries set of thresholds in that case too, if I understood correctly, according to your to what you're saying, also like even a more complex set of boundaries or thresholds would also in a way make us create some expectation that then politics could not then respect. Okay, thank you very much.
Precisely, yeah.
Great, thanks a lot. I wanted to jump in there, but isn't that the problem of inflexibility and path dependency of political systems and policy making as such, rather than modeling, in that particular case only, of planetary boundaries? And I was also, Andrea, I was also thinking of employment policy when you said it, because the second question is, do models help better if they are localized more, take context more into account, help in the sense of injecting knowledge into policy development for a certain situation?
Gabi, I'm sure you have read Zygmunt Bauman, no? He talks about liquid society, and one feature of the liquid society is a divorce between power and policy. This means that our policymakers have less and less power because they are forced to make promises, reduce taxes, increase spending, which are clearly in conflict. And so each administration kicks the can down the road to the next. So because the politicians have no money to enact any serious reform, what they do is that they appeal to, for instance, to identity politics. They discuss abortion, they discuss gay people, you know, the right-wing government want to go after the, you know, the LGBT plus community, and, you know, all this kind of madness, no? But why? Because, you know, this is the only thing they can discuss about. They can discuss about those topics because they don't have the resources, the power to enact the policy which their constituency would need, no? So, and we see this in every country. No, we see. Look, what will happen in the UK in a few days. I'm really curious to see what Stammers will do, no, to meet his promises. I'm really curious. Let's say we shall see very soon. So, yes, you are right. There is an inflexibility into policy, which is due to the nature of democracy, which has this kind of cycle whereby it becomes ossified. Sorry, then you said your
The second thing, how about, so in the overall debate about quantification and the use of statistics for policymaking, we talk a lot about localization of indicators.
Yeah, yes,
That
localization.
those are best used when they are when context is injected. Is that a way for modeling to go?
In a sense, yes. I mean, okay, so we go again back to Bauman. Bauman says another characteristic of liquid society is that local authorities are forced to find local solution for global problem. Okay, so my answer to your question would be yes. The problem is that most problems affecting local communities like nations or counties or regions or city, typically city. The mayor of major cities are totally powerless. I've seen this for Rome. Rome is a very clear example. They are totally powerless. They cannot do anything. They cannot even collect their own garbage, okay? But because, you know, the problem which are pressuring on the city are global, but you cannot offer local solution to global problems. Okay, this is really another paradox, no? So, of course, yes, you are right. It would be much more reasonable to model at the local scale, also because there you could have this kind of co-production. Now you could have more easily stakeholders around the table if you are discussing a particular aquifer or a particular road or a particular train line in a particular region. Of course, yes. The point is that very often the kind of pressure brought to bear on those authorities are global, and they cannot do anything about that. You know, they can discuss about migration as much as they like, but they cannot do anything from left and right to change the fact that people will migrate. You know, this is really a global phenomenon. It's very difficult to find solution. I mean, when you look at the solution they find, you know, sometimes they are crazy or laughable, like the idea of shipping people to Ghana. I mean, you know, at an incredible cost to the taxpayer. You look, you know, those politicians really show us every day how powerless, in a sense, they are, no?
How does, and that's really a question for knowledge, because I don't have any expertise of that. How does modeling affect local politics? Do you have an insight there?
Oh, yes, yes. There are very good examples. If you go in the manifesto, for example, there are examples of
your 2020 manifesto.
Flooding risk, flooding risk can be very effectively discussed at the local level using mathematical modeling. And this has been done with excellent results, because when it comes to flooding, local community have records for it. Now they know more than the people in the hydrology section of the environmental ministry. No, also fisheries. Also with fisheries, fishermen normally have much more knowledge about the stocks and periodicity in catch than the people in the Ministry of Agriculture and Fishery. So there are very, I mean, I dare say that all the virtuous examples of co-production of mathematical modeling with stakeholders are local. Okay.
Is that, would that be for some areas that you analyzed a way out of the problems that you would tend to identify, for instance, in climate change at global level?
Yeah, I mean, exactly. Why not? I mean, you could say, okay, I discuss this when I go to Bergen to discuss this with a student. We want to decarbonize Bergen in 3 decades. Okay, let's discuss pros and cons and how to do that, you know, with the constituencies in Bergen, keeping all phenomena into account, you know, without having forbidden area, no? Who should give up what and in what time frame? Who would be the winners? Who would be the losers? How the loser would be compensated? This could become a very practical discussion, much better than saying Norway respect a threshold which has been established in Paris for emission, and they do this because they outsource production in other countries, you know. And
is there a school of modeling subsidiarity, or rather subsidiarity in modeling? Is there a school of thought that deals with that?
Well, I think that all the fathers of the ecological movement are scholars in this direction.
Okay.
No?
Okay.
Charlie Hall or I don't know, Robert Rosen, you know, they all go in this direction, no?
Okay.
They all go in this direction. So the model, they encourage students to go out, collect the data, and build a model based the data they have collected, and make the model as simple as possible, so that the variable can be identified to start with. Because if you build an over-parameterized model, you will never be able to calibrate it, no? So a way to keep the modeling hubris under check. No, I mean, relational ecologists mostly know these things very well. They have been studying this for a very long time. Those things are a bit less well known in economics, in econometrics, but in ecology they are I would say well known.
Okay, so there's also a school of thought that would speak to what Francesca said.
If we could speak more, yes. If you had more chances of exchange, yes.
Okay, great. And maybe the move towards what we've discussed before, open science, will open up this leeway for alternative schools of thoughts to be more present in the overall debate.
But then this is another seminar.
Absolutely.
This is another
seminar. Absolutely. Unless there are no questions anymore from anyone in the audience, Andrea, I would like to thank you once again for such an inspiring talk and a lot of reading material for the summer break, I assume, for many people. And
I hope you have something better to do, but
no, that depends on the point of view and assessment.
Okay.
So thank you very much for your insights from your book. And we do indeed stay in touch, because what we will do after the summer break, we are currently wrapping together a book on data and indicators for the Sustainable Development Goals, where we are also working on these normative aspects and how statistics and quantification impacts how we measure societies and how we define societies. So on the visible numbers part more, as you said, than on the invisible numbers. And
happy to join.
Super, great. We will keep you up to speed with that.
Okay.
For us as a cluster, as I said, please let us know any type of research that you want to present and discuss in our cluster meetings, and a call for expression of interest will be sent after the summer break. And for now, actually, to all of you, and Andrea, to you especially, with special thanks, a very, very nice summer break with a lot of nice readings or anything else you want to do in terms of recreational efforts. And we will see each other again in September after the summer break. Yeah, and Andrea, we stay in touch and exchange the information that we discussed about before.
Okay.
Yeah, great. Thank you very much.
Goodbye. Thank you.
Bye. Ciao, ciao.
Thanks for the question.
Thanks.